Hello, welcome. This is Birdy. Welcome to a new series in Houdini, Pyro in Houdini. Today we will continue our journey in the smoke simulation in the Houdini, and we will dig deeper inside the DOP network, and we will explore the shape parameters and the micro solver in the Pyro simulation. So let's get started. So let's continue, guys, our journey in the smoke simulation. Okay, and let's dig deeper in the PyroSolver. So after we explain all the simulation in the last lesson, now we will move to the other panel. But it will not be composition, because composition we use it when we have a fuel or when we want to make a fire, and this series is for smoke. The first series in Pyro will be for smoke only, so we're not going to use composition, and we will use it in the Pyro series or in the fire series, I mean. So let's move to the next panel, is the shape. Now we have all these parameters. We can reach this parameter in two ways. First way, it's built-in parameter in the PyroSolver, so we don't have to add it, or we can add it by the microsolver. As we can see here, we have a microsolver. As we can see here, all the gas microsolver is here, and we can use any gas turbulence, for example. This is gas turbulence, and we have also here the turbulence. Both are the same, but with the gas turbulence it has more option. For example, let me do the parameter for the gas turbulence, and let's stand here, and of course to initiate any of this function or any of this microsolver, you have to check it. So I have to check the turbulence, and now if we go here, we will find turbulence. Here is the turbulence. Of course, all of this is the option for every one of this microsolver. Okay, and it initiated when we check it. As we can see here, it become dull. You cannot do anything about it. If you want to initiate it, you check the turbulence. Okay, so let's check fast the turbulence. We have swirl size, here, we have green pulse. All of this option is here, but we have still maybe one or two more option. This is the first. Second, if we go to the control settings, we have control settings here also, but here it's checked and here is not checked. By default it's checked here. Then we have visualization. We have also here visualization, I think same parameters. Then we have temporary fields. We don't have a temporary fields here, as we can see. We have only bindings, and here also we have the bindings. Also here we have something called stencil field. It's new, I think in 17.5 and 18. Okay, and also we have here advanced if you want to use the OpenCL. Okay, but as always, I don't recommend to use OpenCL unless you have very powerful computer. Okay. Okay, so we will start using the built-in microsolver in the PyroSolver. Then we will use in the next lesson, or maybe next two lessons, the microsolver. Okay, so we'll start by dissipate. What is dissipate? Dissipate simply It's by its name. Dissipate is make the density after after amount of time disappear. Okay, this is the first thing. So let us check it as we do earlier. We'll make we will make, let me check something here. Yeah, okay, perfect. We will make just a flip book just to compare and to see the difference. Okay, so let's start, and I will back to you after it's finished. So as we can see here, this is the simulation. Now we will make a sequence list, then a new sequence, and let's check dissipation, and let's type a big number. Let's see first what's written. Cause smoke density to disappear over time. Low value cause smoke to disappear slowly. High value cause smoke to disappear quickly. Okay, that's meaning this small number will make the smoke disappear slowly. If we put 1, or let's say 0.9, it will make the smoke disappear very quickly. So let's make another render or flipbook to see the different. I will back to you after it's finished. So let's make the comparison. Play. Let's see the other. As we can see here, the density become much less. As we can see here, after we check the dissipation and put a big value like 0.9, as we can see here, the intensity or the density of the smoke, it become much smaller, as we can see, but it has the same simulation. The simulation itself, it didn't change, right? Same same mushroom shape that we have, right? But the only thing that changed, the density of the smoke become much less, so it disappeared very fast. Okay, so this is the first thing. So let's also see, let's make a new sequence. Let's also understand the control field, because control field will repeat in every microsolver. So what is control field? Control field simply control the strength of the microsolver from a certain field. Meaning we have here temperature. Let's see the temperature here, for example. So we have the control range from 0 to 1. All this black is 0, and all this white is 1 and above. Okay, for the value of the temperature, yani this black contain 0 temperature, and this light color, white color, contain 1 and more. Okay, 1 and above, 2, 3, 5. Okay, so as we can see here, the strength, this is the strength of the dissipation for the smoke. So as we can see here, the strength of the dissipation, it will have its maximum, okay, this number, in the temperature 0, meaning when the temperature is very low, very low, like 0, it will have its most powerful strength for the dissipation to work, to take over. And as much as the temperature start to low and become much colder, okay, the line of the strength of the dissipate started to become much low. So meaning this one, for example, meaning this value is 0.873. That means this number will multiply in this number. So every temperature, every voxel has this amount of temperature. Okay, it will be multiplied in this number. Yani this will be one complete. Yani every voxel has 0 temperature. Okay, this is 1, meaning this is 0. Yani this is 0. Control panel, this is 0 until 1. Okay, so it will has full dissipate. Then when it start to become much weaker, we will take this number, multiply in this number. So the dissipation on the density field will have this amount multiplied by this, and so on until 1 temperature. It will has almost 0 dissipate, meaning all the smoke, meaning all the hot smoke we will have 0 dissipate. And when it started to get colder, it will start to dissipate. Okay, so that's why we can control the dissipate from this field. We can also then change this field to velocity, for example, velocity. Think velocity, and also it will work, but it will work in the velocity, meaning all this velocity that has 0, it will has 0, it will has full strength for the dissipate. And when it started to become has more strong velocity, the dissipate will become much weaker, and so on. Okay, so this is for the this for the dissipate. Okay, and of course it affect the temperature. Let's make it temperature. Of course it controls the density itself, the density. Okay, so next we have the disturbance. What is disturbance? Disturbance, first of all, the field that will be disturbed is the velocity. We can change it here from the temperature or the velocity. Let's check here to see the velocity. This is the full velocity. If we go back here, we choose the dissipate. Now we have as we can see, now we dissipate the velocity. As we can see here, now it has many noise, like noise or swirl noise, right? Okay, but how it work here? It's right cut out and cut off. I think it's for the density. It work by the density. Yes, voxel cut off. Yes. Let me check it again. Voxel with value higher than this value of the cutoff will not be disturbed. Perfect. So here the disturb effect use the velocity or affect the velocity by the amount of the density. This cut off for the density, meaning any voxel has amount of 0.15 or bigger than this amount for the density. This is for the density field. This is the density field. Okay, so any voxel has this amount of density or more will not be disturbed, will not be affected by disturb. Only this amount and less than this it will be disturbed in the density field, the smoke, by the velocity. Okay, so in meaning it make like I'm not sure about the English word, let me see it. Okay, so it will make something like a protrusion, as we can see here, only on the surface of the smoke itself, but it's not going to change the shape of the simulation, but only it add protrusion or protrusion, something like this, on the surface itself. So let's make another flipbook just to see. Of course, when we add a bigger value, we will have more effect. Let's make it 1.9, for example. Let's do start. So let's compare this with the disturb and this without the disturb. As we can see, we have we cannot say the same simulation, but it's very near yani. Okay, but it has these small details on the surface itself, small details, and so on. So it adds details, as we can see here, it adds details on the surface, and it makes this I'm not sure about the word tunkles, or I cannot remember the word, but things like this. Okay, so the block size can control the size of this protrusion. Okay, it's a size. So block size mean 0.2, mean we will have if we go here, if we make a box, let's type it 0.25. Here, one. Let us move it like this. So this will be the size of it, the size of this detail. Okay, so we can make it smaller or much bigger as we want. Here we only have one, but if we want to make many, for example, I can do it by the gas disturb. I can make many, something like this. I will say this will be of course in the newest version it has come something called reference scale, will be equal to the strength, it will be equal of the strength when mode is set to continuous. Provide a scale for normalizing the force against voxel size. A larger value for this parameter will increase magnitude of the applied force. Okay, so this will increase the applied of the magnitude force, but we have the block size here as well. We can make it 0.1 maybe, and we can do another one. And this one it's 0.1 and this one will be 0.2. we can merge it together both here, connect it here and then connect it here. So now we will have two disturb but with different size. The first size is 0.1 and the second size is 0.2, and this is the pulse length, meaning it change by time. Then we have intensity and roughness and max. It's almost same like noise. Okay, so this is when we want to use the gas, the microsolver. It give us more flexibility, okay, to make many effects for the same effect but many sizes. Let's continue. Now we have the shredding. As we can see, shredding. Oh, but maybe I can see if there is something only I want to speak about the disturb. Yeah, I think I said enough about the disturb. Now let's continue to the shredding. So the shredding makes a squash and stretch for the smoke. It gives us the effect of the squash and stretch for the smoke, and it work by the temperature itself, threshold temperature, and usually we use it more when we have let me see, push and build the velocity field based on the gradient of the heat field to create the streaks, separation and leaks typical of fire. So as we can see here, we usually use it for fire more, okay, because of course PyroSolver, it can turn to a fire if we enable the composition and we have a fuel as well, okay. So but maybe we can see its effects as well. So let's make another flip book and hit start. No, okay. So as we can see here, it make a little different. As we can see here, we have all this line, new line. Before we didn't have it, and also the smoke was raised up straight, but now it's changed a little bit its direction. But as we can see here, now we have more this shredding, this shred, right? It's like someone shredded, and it has squash and stretch. Uh, so this its effect. Okay, now let's continue. As I said, it's used more with fire to give the flame the effect of the fire of the flame. So let's continue. This is called sharpening feature in the velocity field. So it affects the velocity field, making smoke more wispy, sticky, rather than soft, fluffy. Okay. So rather than fluffy is like the cloud. This is fluffy. A cloud is a fluffy, but wispy or sticky, it's more like a cigarette. Or also, as we can see here, this wispy smoke. As we can see, this wispy smoke. So the smoke that it's from a cigarette, from maybe a hot cup of tea or coffee, okay, anything hot, right? So this is the sharpening. It give us, it give the smoke more wispy, streaky than soft, fluffy. This can be useful when you are not using much shredding to increase the definition of the feature in the flame. So usually as well we use it in the flame, but over shaping can give artifacts in the volume. It can give us artifacts, okay, and the artifact is not good in the simulation. It show it's artificial, not realistic, okay. As always, let's make a sharpening to see its effect. So let's check. I make the amount 0.9 to see the, let's compare. Let's compare. This is without and this with. As we can see, it give it a little more As we can see, yeah, it gives some transparency in some areas, and the other it make it density, so it make variety, right? So it's becoming like a smoke of cigarette, something like this, right? As we can see here, like X-ray or something, right? As we can see here. Let's continue. Now we have the turbulence. What is turbulence? What is turbulence? Turbulence, same as turbulence noise when we use it in the attribute VOP, right? The attribute node, or the node called turbulence noise in the attribute VOP, right? It makes swirl inside the smoke itself. Let's check first what is turbulence. Turbulence adds churning noise to the velocity field, so it affects the velocity field. You should generally use this to add powerful, large scale, low frequency noise, and really on shredding for smaller features. This is especially useful when you have a very fast moving fire and you want to add more character to it. So when you have a very fast moving fire and you want to add more character to it, use turbulence. Okay, but turbulence different than disturbance. Disturbance, if we check here how it's work, the control field, of course, it affect the velocity field same as the disturbance field. Both affect the velocity. Okay, but here is the opposite, meaning the control field itself, when we have a low when we have a very low density, so it will not going to work. And when the density started to get density, the smoke, when the smoke started to get more density, it will start to take over and affect the velocity field. Okay, until when it will have full strength. The turbulence will have full strength on the velocity field. Meaning, if we go here and we have the velocity, let's play. Yeah, let's make it 1. So as we can see, the outer area is not affected more than the interior area, which has more density for the smoke. The smoke here has more density, so that's why it affects more. And of course we can control the swirl size, maybe make it much smaller, like 0.2 for example. It will make it much smaller, as we can see here now. As we can see, it only affects inside the smoke itself. So outside the smoke, or the surface of the smoke, it will not affect it much than the inside itself. And usually it change the shape of the smoke itself, not the surface, like turbulence, disturbance, I'm sorry. Okay, so as we can see here, the disturb affect the outer only, right? Inside here I can show you, maybe if we go to the velocity here, maybe we can do something like this. Yeah, as we can see here, the disturb affect the outer, but not the inside the smoke or heavy smoke. Okay, but the turbulence do the opposite. Turbulence do, as we can see here now, the outer almost didn't affect by the turbulence, but the insider really affected by the turbulence, right? So to also judge by the widget, let's make a compare to see the difference. Let's say start. So as we can see here, it has its effect, but its effect is a small effect because I made the swirl size is very small size. As we can see here, swirl size is 0.2. Let's make it 1, so it will make a big difference. Let us check it. New sequence, flipbook, start. So as we can see here now, after we change the swirl size, it become very different. As we can see here, the swirl size was small, so it still has the same smoke shape like before, but here yeah, of course we need to change this here, but here when we make the swirl size bigger, so it started to affect the smoke itself and change its shape completely, not the surface only. Okay, and of course visualization, it has a visualization. If you want to see the visualization here, as we can see here, it show you its effect, where if its effect will take place here, as we can see. Okay, and I think disturb also, no, it doesn't have a, but I think in the gas disturb, maybe in the gas disturb has a visualization. Yeah, it has a visualization as well. If we add this here and let me check the turbulence. Yeah, so this is the effect of the disturb. Okay, and of course we can choose many control settings, 0.2, maybe block paste, maybe 0.2, maybe 0.05, maybe add it to merge and add this here. Yeah, and also add gas turbulence like this. And also you can control the swirl size, maybe big swirl size, maybe small swirl size, maybe you can make a boss, something like this. Maybe this is the scale is strength, and this is the size, maybe 0.9, something like this. So we will have a different shape now. We don't need the shape here, but we can use it here, and also we can use only the dissipate, maybe 1.2. Let's check it. Render new sequence, start. So as we can see here, its effect now, it become much from this to this. There's a huge difference from this to this, right? Now it has much detail, and also we can use like shredding or things like this. The last one is the confinement. It control the, you have to check it here as well to make it work. Usually confinement, let's see what is confinement. Puts swirl vorticity where they exist, increasing curl lines in the simulation that would otherwise to be lost by the grid resolution. Too high values can make the simulation unstable, and low up negative values suppress vortices and smooth out the simulation, but it's usually better to just use a lower resolution grid like one. But I'm not going to use the conf. I will use it as a confinement, vortex confinement, this one. It will give us the same effect. Usually we use this in the last one, and this has a confinement, same thing. So let's make another render to see the different, if it has a different. Let's make a flipbook and let's start. So let's check if there is a different. We check it here. Yeah, I don't see much different. Maybe it will be more obvious when we increase the resolution. And also I want to say that we can increase the resolution, of course, by increase this number. I will copy this parameter. I think I do it, I'm not sure, and paste it here. Yeah, I think I did it in last previous lesson, right? So yeah, I think this is it for the PyroSolver. We have also diversion gas project non-diversion, but I think the diversion we use it in the expand. When we have an expand or something, I think we use the diversions. So now we're not going to use it, or maybe just for the sake of experiment diversions. Let's see if we use the diversions here. What's going to happen? This one, yeah, gas, okay, gas, okay. Let's check it for the last time. Render, a second. Start. I want to say that the simulation was very slow to make the caching. So let's check the effect before. I don't see a big difference. Not really different. Maybe not in this example. Maybe we'll see another example and use the gas divergence or the divergence. As I said, divergent use in the expand. Okay, so and that was the end of this lesson. I hope you enjoyed. If you have any question, please type it in the comment section under the video, and please don't forget to like the video and subscribe for the channel and share it with your friends. And if you would like to support us, you will find below the video link on Patreon and Gumroad, and we appreciate your support. Thank you and see you in the next lesson. Have a good day.